So, good afternoon. My name is Marie-Françoise Voidrot, and I will today chair this session about leveraging the Earth observation European infrastructure. I will share my screen for a small introduction. So, let me share my screen here. I hope you see my screen. Okay. So, as mentioned before, eShape is gathering 55 partners, 7 showcases, 27 pilots, and soon more. And we have a 4-year grant. As mentioned, this is a super panel to understand where is the Earth observation community in terms of understanding and vision of the resources which are available. And what we expect is to get a lot of return on experience from these 27 pilots. And these 4-year grants give us a clear target, but of course we will communicate and we want to interact with the broader Earth observation community, and this is typically what we are doing today. Because I don't know who could attend the presentation I have done this morning, I will just want to repeat something which is super important to me, is that right now we are working on 51 platforms which have been identified to date as being used or planned to be used by the pilots. And we try to interact, we would like to interact more intensively with these platforms, but of course it is also open to more. And the goal is not to push any competition, but to identify the best fit for use. I strongly believe that no platform can host all the data which is available for many different reasons. For reasons which are objects of confidentiality, you can have public data, you can have private data, defense data, but also for reasons of technologies, for reasons of volumes, of cost. So this is why having several and even many platforms is maybe not a problem. Of course, what is difficult is that this makes the landscape very complicated to the user to understand. And the goal of eShape is to identify the best assets and to build a vision that will make all this landscape much more easy for the users. So during the first year, because eShape is now 1 year and almost a half, we have worked on defining the process to interact with this structure of the project, so the different work package. And here, mainly for the work package 3 implementation that I am leading, the interaction with the pilots and showcases. I will present this methodology tomorrow, and I hope you will be able to attend. But this is mainly on how we work and how we are going to onboard the next pilots. Now, what I would like to do is here we are discussing at the level of the project management interactions with the partners, and these partners are typically the platforms, because eShape is only developing pilots. We are not supposed to develop platforms. So these platforms partners are external partners, and we want to work on defining the best interaction with you. So why do I say the best interaction? Because this this Earth observation landscape is very complex. And what we have seen is that to be a data scientist, we need multidisciplinary teams. And very often in Europe, because we are more fragmented than in the US, where in the US they might have a full team or full laboratory, we might have maybe in Europe, in each country, 3 or 4 people working on that. And so the idea is that because we are more fragmented in terms of organization and in terms of skills and so on, we have to work on the interfaces and on the interaction. And what we have identified is typically that data scientists need to have some technical skills, but the cloud computing is not a skill which is commonly shared among the Earth observation data scientists. And this is why we think that there is a very important topic here to deepen, how to support the interaction between the users, the scientists, and you platform providers. So what we have seen that are questions that come very often from the pilots are about the user interaction, how to better interact with the user on the web, because this is new for them. How is the registration process? How easy is it? The authentication, how does it work? And especially into a system of systems where you have to go from a platform to another platform. Considering the data, how to handle specific needs. We have seen this question coming back very often in the dialogue with the platforms that offer already an existing data catalog, but how flexible are you to handle specific needs? Do you recommend to access the data on a different platform? What if some data is missing for the pilot? The policy to enrich the data catalog. How can external data in situ commercially available proprietary be included into the processing scheme? What do you recommend, direct upload versus remote access? Is the data you provide quality checked? And considering data search, how efficient are the data search? Considering the cloud technologies, we have already identified a need of capacity development to prepare the pilots to be scalable, to prepare the pilots to be deployable with Docker, Kubernetes, Hadoop, all the big data and cloud technologies. On cloud technologies, how to specify the technical needs to the platform providers to facilitate the interaction. Considering the assessment of the cloud technologies, the capacity to handle full brokerage mechanism from the GeoDAD, the provided tools and services by the platforms, and which are the processing policies. Then when you have access to data, when you have a process, you want to make your results visible. So to get the results visible, what if some pilots want to publish data or services into the marketplace? Is it open to all? If open, what is the process to publish the data or to publish an application, which is like data, but with some interaction with the user? The cost is a question we always have because the pricing lists are very complex to use. We have some examples of pilots that need to work on several small locations, and depending on the size of the location, the calculation can be very complex. What about the SLA? Do you provide the SLA 7 days over 7, 24 hours? Considering the sustainability, which are the risks with the platforms and the benefits to move from another platform, which are the interoperability arrangements and which are the selection criteria? Even this morning during my presentation, these questions popped up. How do you recommend and what is the process to select a platform? So what I would like to discuss today, I would like you to understand that we do not want to put you in competition. What we want to do is really interact to help you. And how can all these Eurogeo and E-Shape pilots can help mature the dialogue between application providers and infrastructure providers for the benefit of all. And what are the bottlenecks to the uptake of platform as a service for Earth observation application? How far are we from an efficient and effective value chain? Here, what we want to identify is the pinpoint we can work on during the project to help the global community and go faster together, faster and further. So the program today is very tight. I ask you to prepare a presentation in 10 minutes. I will show my video when you will reach 8 minutes to help you wrap up in 2 minutes. Because as we are numerous, we had some late birds arriving, which are not the last one, by the way, because the order is not reflecting when you answered. And we will just have 15 minutes of discussion. So please keep the timing to allow us to discuss a little bit at the end. Thank you very much. I will release my screen now and will give the floor to Heike. I stop sharing here.
Yes, hello, everybody.
We can see you.
You also see my screen?
Yes.
Yeah, very good. So Hello, everybody. Thanks for the invitation. My name is Heike Bach. I'm from the company Vista. And although I'm presenting now here ESA's thematic exploitation platform, so I'm not member of ESA, but I try to wrap the different tabs that are available together. And Vista ourselves, we are responsible for the food security tab. So that shows you the general vision of ESA on big data exploitation platforms. So it shows that we try to use platform as enabling technology, and we are using a wide set of data, not only satellite data, also ancillary data. And we have infrastructure in the background, processing and storage capacity. And also important is we have toolboxes available on these tabs that allow data analytics and to use them also to publish them and make them available to others. So we have remote access where you can do all the things. And the general idea is bringing the users to the data. Service providers play a large role in this because it's not so much an very end platform like for farmers or for single citizens. It's more for administration, public authorities, companies, institutions, and service providers as well. Looking a little bit deeper, I tried to summarize what the tabs are, what the main features of them is. I think importantly is we have 7 of them. You see the different logos of them, and each have a different field of application. So the general idea is they are user-centric and user-centric, and that, for example, there is a hydrological user, then he has access through the hydrological tab, and then have access to the platform and the services on the platform. I think that's quite important because each user has different requirements. What all the platforms have in common is that they're using a platform as a service that are the DIAS systems, the DIAS ecosystems. Mostly or most frequently is GreoDIAS used, but also ONDA is used and others. So it's not a comprehensive list of it. And all of them are using the infrastructure as a service, the data, Copernicus space and ground segment data is used, but also other satellite data and other data sources are used. So we have data provider, platform provider, and the tabs we understand ourselves as information as a service providers on top of it. So we need here algorithms for this and always also services. To summarize, and always when you see the orange color, it's my personal summary of it. It's not ESA approved. So we see we have a user-centric approach, and the application domain really determines the tools, data, and services to be provided, because it's not the same whether you are at geohazards, then you need, for example, very much coherence analysis and SAR data compared to hydrology, where you need optical data in the visible bands with a high quality there. So it's really depending on the user and application what you do. And we always see we need federation with other application-oriented platforms. It's not that we are standing alone. Federation of platform is always included and quite important. We don't have to host all the data, but we have to connect to them. And for the user who goes into the portal, it should be not play a role, whether the data is on this server or on that server. It should be at one access point available to him as an application-oriented user. To sum up the different tabs, here you also see the name and the application area. They started already in 2013 with the first one, but the most in 2015. And then we went through a development phase leading to pre-operationals, and then finally the green button is the operational phase of the tabs. So summary the status of this year, we have now over 80 services operational running and offered, with more than 3,000 users that are using the services, which is quite a success. And we also have a strong community base because we are so user-centric. We have workshops and meetings with them and develop with them. So of course, the user communities are separate, but they are very much strong. We have many international collaborations. Just to mention very important ones, I think the 10 EU projects that we are supporting, most of them are Horizon 2020, which are already use the tabs. But you also see in this time schedule, the time to operations vary, depend on the service, it depends whether you have a very operational or services that are already very close to the market, or other that maybe stay longer in pre-operations because they are not so commercialized, like geohazard is more public interest in this. You will also see our food security tab started a bit later, but we succeeded to catch up and are now in operations. Conclusion again is we have, I think the user or application-centric approach appears to be successful, but we also see the establishment of platform requires time, often much longer than normal project lifetimes. You have 3-4 years, and after that, nobody knows how sustainable the whole procedure is. I know this also from other projects. And you just see you need time, you need 4 years until everything runs as expected. So that is, I think that's also maybe a challenge for eShape later on. Shortly on the food security tab to show you as one example how all the tabs work. For this food security tab, we want to use satellite data and other spatial information to sustainably increase agriculture and aquaculture productivity. We want to help farmers adapt to global change and improve early warning initiatives. So we really have a focus on our applications, and everything is streamlined to that. So then this means it's streamlined, but still we have a diverse user community. It's not just public bodies that are using the tab. For example, it's also agriculture industry, and they have specific needs. They want to have custom serviced that are quality check products that they can just have access like from the shelf and can say, okay, I know I can buy these products there, which I need for my businesses. That can be agri-suppliers, for example. They don't have to be all service providers, that's all in this case. They don't have to know anything about Earth observation. Then there are the group of service providers who are using the Earth observation and develop themselves. So they need access to parallel processing, massive computer power. They need to have an easy service delivery to their client, and they need a secure and stable platform. So completely different requirements for the platform. And we also have public sector organizations, and when you look at them, they want mostly low-cost services, and they want to have free and open user interfaces, as everything should be free and open, and they are thinking more in the scientific and humanitarian work. This is their access. So we see the list of users is just a selection of them. It's just very diverse, and according to this, you need different tools to be offered. Also different cost schemes. I mean, cost is always a point. How do you cost your services, or how do you charge your services? That is really one of the complicated issues that we have. And in this platform, all in common is all the tabs. We have access to satellite data. We have access to massive infrastructure for processing. Of course, we use Docker and Kubernetes for parallel processing and so on. We have data sharing possibilities, publication options, and account management and service billing. That's all needed. But maybe more importantly is for the tabs, the user-specific tabs, we need data archives that really fit the agricultural needs. We need complementary data sets for agriculture. For example, we are interested in yield statistics, or we in the LPIS system for Europe, which hydro system is maybe not interested at all. And these data will be available to the users on the platform. And we have also dedicated services for agriculture, for example, yield forecast service or a fertilization service. And with this, we have ready-to-use processing services, like, for example, that people can process the leaf area or crop indices on request. Examples from our partners in the tab, from Vito, for example, an index insurance case in Africa, and from the partner Hatfield from Canada, it's a mangrove mapping service, which we develop with the partners here, Pula and FRO, and where the local people can also use the services and look at the products and learn from them and adapt them to their needs. That's the idea. Summarizing the tab concept, you've seen that before. There is now some new things coming up that is now in gray that ESA is supporting. It's number one is to make it a little bit more complicated. What we have, the network of resources, which offers additionally a marketplace to all the services of the tab and a billing infrastructure. And it also offers access to other satellite data. And it will also have a connection to the European and other data cubes. That's the idea. So it will support all of the tabs, being the binding over all the tabs. My summary or my view of these new activities of ESA is, I think the idea of joining forces for billing and marketing is very positive. That helps us that we have joint common solutions. And I think this offer should not be limited to only ESA activities, that also others could benefit from this and interlink with each other. But I think on the other side, if we only have the access point of network of resources, the user and application-centric approach gets lost. You have everything on this portal, and it will not be easy for the really user to have access to it. So I think it's not desirable to only have one access point. We should keep the access points with the user in the application domain, but still use the services from an overarching service like network of resources. Now, I also want to address the questions that you raised at the end very specifically. What are the bottlenecks for the uptake of the platform as a service for AO applications? I think important is we don't need a platform monopoly or a centralized marketplace. But it would be important to have a few, not 50, but a few access points to the services which are interlinked, that people find their way. And I think activities and projects like eShapes are very helpful for the downstream users and help them also to onboard on the platform technically. That is very interesting to join forces and collaborate there. Concerning the use of the platforms by service providers, I see the problem that there are at present too many different technical solutions, and you have to understand them as a service provider, learn about them, and if they are not compatible, it's quite always months of time until you have your service running on the specific platform, which is too long. And also there is a problem that many platforms are, I would say, underfunded because they have a limited time span of funding, and then they have not enough budget to survive. Or others, mainly from the larger companies, they have very specific products because they want to push their own products, which is also not helpful because you don't have the full set of availabilities there. So that is this point of view. And also the last question that I want to answer is, are we far from an efficient and effective value chain for Earth observation? Absolutely, I don't think so, that we are far away. We have good examples that things are running, and just during the last year, it has evolved a lot. But I think it would be desirable to have a user-centric information as a service providers that are visible on the platform, and that they can use standardized platform functionalities which are offered by a group of infrastructure as a service and platform as a service providers, like, for example, the DSS. There are just 4. It's not only one, important. They have strengths and weaknesses, and you select the one that fits most. But also importantly, they have similar technical standards that we can choose from one to the other. So we have not a locked-in situation that each service provider is fearing. And we also, with this, we would also avoid building of monopolies. I think as long as one company doesn't want to have the cake on its own, as many American model, as I see the American model, I think we have the chance to achieve an alternative European model, which includes data privacy and a fair competition of the different service providers. But maybe one step forward to allow this is that we should demand that European research funds should preferably use also European platforms. I mean, I think that other platforms mostly Google and Amazon Web Services are used by large initiatives in Europe, and not supporting the platforms that we have in Europe is not a good solution so far. And it doesn't allow to ensure data protection, also IPR protection, your knowledge and your science results that might be get lost. And this would also allow that we would counteract monopolies. Okay, that was it from my side. Thank you.
Well, thank you very much, Heike. I think we will skip questions. Thank you to have addressed the questions, and you have already answered also some questions I have seen into the Q&A. I think we will put the questions at the end, because if not, we might have trouble to finish the session. So Next speaker is Stanisław Krzyżanowski from Claudias. I hope I say it well. Apologies if not. Stanisław? Stanisław, I can see you are here, but we do not hear and not see you. Oh, hello. We cannot hear you. Heike, can you release the screen maybe? Stanisław?
Yes. Can you hear me now?
Yes, we can hear you. We don't see you anymore, but we can hear you.
Okay, I will share my presentation
Okay.
then.
This is nice. Okay, thanks.
Hello, my name is Stanisław Krzyżanowski. I'm working at Cloudferro as a business development specialist. Thank you for inviting me. It's an honor to be able to present to you. Today, I would like to very quickly share with you some lessons learned from our activities as a DIAS provider. It will be a success story because we want to lead by an example. Some of you probably have heard about the Sen4CAP project. That is basically an application for crop classification used by paid agencies. And on the basis of this application, on the basis of the way it has been implemented and integrated into the CREA-DIAS environment, I would like to show you and translate it to some more universal lessons and requirements to make a successful product, successful application. Sen4CAP is the Sentinels for Common Agricultural Policy. It's a project set up by ESA, created in cooperation by a couple well-known and very experienced stakeholders. It was implemented on the DIASes on the request of the European Space Agency. It was adapted for the DIAS environment. Its main customer are agriculture paying agencies. It takes advantage of the Copernicus data and some reference data. And what can we learn from this from our success with this application? I'm saying that we had a successful run with the Sen4CAP because it's an application that has been implemented well almost a year ago. And
excuse me, Stan, we are stuck on the title slide. Is that normal?
No, you should not be sitting on the title slide. You should be. Are you not seeing? I'm sorry. Have I managed to switch the slide? Yes.
Yes.
I'm sorry then for the technical problems. As I mentioned, our success story of the CREA-DIAS that translates to some more universal lessons. I explain to you what the Sen4CAP is. So, what are the lessons? What are the requirements for the successful development and deployment of an EO-based application are from the perspective of the DIAS provider, so research provider. The first thing is the legislative support from national and international bodies. We observe as a provider that in the domains where there is a support from legal entities, from legislative entities, that is area focused, so domain focused. We have more growth, more results that impact the final users. The second requirement is awareness. Obviously, every stakeholder that is taking part in the process has to be aware of the resources and capabilities that are available at any given time. Subsequent requirement is cooperation. In order to, even if you're aware of existing resources, in order to take advantage of them, you have to be able to cooperate. You have to define stakeholders. So choose the platform. As, for example, as an application provider, you have to choose the platform, choose the resources you need. You have to define the final user. As was with the with our success story example, the Cenfor Cup. In order to achieve success, you had to define the final users that were the paying agencies, define the data, and define the platforms. In this case, the DIASes. What else is required? Obviously, the data and the computing power. That's what the platforms are for. You have to know what data can you use and what data might be useful. So expertise in this area as well. You have to know what resources can be used and how to use them. And that brings us to the final focal point that is always required. I mean, communication. To be able to fully leverage the existing European infrastructure, you have to communicate. You have to communicate with data providers, with infrastructure providers, with application creators, with users, with final users, with international entities and organizations. It's extremely important, and we observed during the last couple of years that it's the communication that makes or breaks many projects and initiatives. So where are we and what we think would be required next? So as for the question of the state of value chains for Earth observation in European industry, we think that this level of maturity of value chains varies between different domains. We have thematic domains that have matured quite nicely. For example, in our opinion, agriculture is one of them, but there are still things that can be done to push it further. As for the awareness, we can observe that majority of the application providers in our industry have quite a good awareness of available resources and platforms. There is still some work to be done in communication with the final users to let them know what they can do, what information they can gather. Next step is the very important role of national, international initiatives that may bring us all together. I mean, the application providers, platform operators, final users, the international agencies. Those initiatives play a vital role in fostering communication and growth of our industry and our community. And almost lastly, international entities should and can support the growth of development of Earth observation value chains in selected domains. Those domains that may be that may have more steps to go still should and may benefit from leading role of the international agencies. And lastly, I would like to second the voice of my predecessor with Europe and for Europe and beyond. What I mean is we have developed European platforms, European infrastructure. We developed European tools. Let's use them. Let's use our infrastructure we have developed. Let's foster that European cooperation. It will not only benefit ourselves, but also benefit the rest of the world, because what we do gathers great interest from many sides of the world. So let's focus on that. Thank you very much. If you have any questions, I'm open to those, and I would pass the microphone to our host. Thank you.
Thank you very much, Stan. You are completing your time, and thank you for your highlights. We will go to next presentation from Franck Ranera from ONDA.
Hello, Marie-Françoise, can you hear me?
Yes, we can hear you.
Yeah, fantastic. So I will share my screen. Okay. I want to put it big. Well, I would like to pick it big, but this should disappear. So wait a second. Okay. So I hope you find, can you see the screen?
Yes.
Okay, fantastic. I will present basically what ONDA is doing is offering as a platform, but my focus will be, I won't spend time on that, but my focus is the word platform. I mean, platform has a different meaning according to the people who are in front of us, according to their level of expertise. So as a DIAS, we are not what some users think or interpret a platform as a graphical user interface from where they can click on a button and derive information and value-added information. The DIAS or ONDA is an enabler of capabilities. Is a place where you can get the computing power and you can get the data. And from that, you build your application, you build your platform, let's say. So just some contextual information that we are all aligned. The DIAS started in June 2018. On ONDA, we decided to be an enabler of capability, as I said before, because the contractual baseline of the DIAS was at the early stages addressed to professional, to experimented user, people that knows how to use this large volume of data, people that knows about the cloud technology, and they know to combine both to take value on that. So, of course, if we stay on that, what the people can get from ONDA is all the cloud resources. They can play with the portfolio, let's say, of the infrastructure. They can optimize the way they search for the data, and then they build the application. So if we stay on that, we are not answering to the full community. We are answering to a niche of experts. So obviously what we decided to do, still being an enabler of capabilities, this means that within ONDA, you will not find a value-added information just clicking on the button. But we decided to extend our capabilities to offer much more than what the contract asks us to offer. And then we developed also some evolution lines that I will quickly describe. So basically, the interface that you can get from ONDA is an Horizon Web Portal interface, from where you can decide the virtual machine, the infrastructure, the network, the storage capabilities, and much more elements that you want to put together to develop your application. What is interesting here, you have the full control, obviously, that's the cloud. It's easy to use. There is a lot of tutorials, and we already provide, of course, provide some support. It's protected, okay? Credential, login, password protected, so there is an authentication process. It is clear in terms of billing. You know exactly what you consume and your consumption. There is no hidden cost. I will not put here the list of the prices of the virtual machine. It will be too long. But let's say that according to the budget that you have, your project or yourself as a private, then you can find what you need. And generally, when you take one of the virtual machine, you have a set of pre-configured tools that are available from where you can either develop your application, or even install other software that you have, or use the algorithms or the script that you have developed. And it is interoperable because it's using the OpenStack standard. It's well known. Everything is free and open. So if you decide one day to move away from ONDA or to come from another OpenStack-based platform, you can use our algorithms on our environment. There is various interfaces that are available. We said just before that a graphical interface is needed, then you will have the catalog. But if you're an expert in programming languages and you already have your script and you don't want to hear about a button and you want to develop everything, then you have the Linux environment. You see, we developed the remote desktop to speak to everybody. There is some customer that wants to see a computer, even in the cloud, and they want to double click on an icon to open software and access the multi-petabyte of data. Then we had the opportunity to develop some specific graphical user interface in the framework of projects, and this is one of the examples. Various interfaces according to the level of expertise of our customer. I won't spend time on the data set. You know, DIAS is providing a lot of data, mainly the Copernicus data and information services from the launch of the mission. Generally, data are from the ESA hub, so they are already data, the quality is checked. We added some elements in our portfolio of data, which is the VHR data with agreement with Maxar, Deimos, Comsat, and others are coming. And there is this aspect of the data hosting. If there is, we are not thinking that we will have all the data that are useful for your project or your applications, but you can upload your own data, license protected data, sensitive data, and this is in a secure environment. And you can combine all this information together to develop your applications. There's some elements that we understood as well, is that we need to help the people to use this system. Again, if we just stay with the basic contractual line of requirements, we are just talking to the experts. So here we decided to say, no, okay, we have to help everybody to use that platform. So if you go in the catalog and if you can identify one product, fantastic, you have the name of this product. But then if you go back in the menu, let's say in the virtual machine, and you just connect to the disk where the data is stored, then you're in front of you for this specific date that you can see for the 7th of April, 2020, you have 12,000 products. So it's not easy to look for this product. So we developed some specific tools. Here's the manual tools, here's the automatic tools that help you to automatic focus, point the product, and either download or analyze remotely the product. There is some other interactive development tools like Jupyter Notebook with the data access mechanism that are there that help you to automatically search, identify, either download or process remotely the product. A lot of tutorials to train the people, to raise the awareness, to raise the confidence in using these tools. Also some webinars, and we develop a service that we call ONDA for Education, where we show to the people how from the data, using the ONDA virtual machine and all the API and tools that we have, you can derive information. ONDA for Education is this one here. I'm listing some elements, and you see that is active in many Copernicus hackathons. That's an example. Obviously, the Jupyter Notebook aspect is interesting because it's using a lot of data, obviously, but you can configure it with different programming languages. And we decided to add to that not only the tools, but the people, the experts that are there. That's what we call the scientific support, using the ONDA API and the infrastructure. So it's both on the API, the infrastructure, and the science that is behind the data to help you building your application. Some are experts, they don't need us, but other ones, they understand the rationale, they understand the benefit they can get from space, but they don't know how to use it. So that's what we try to respond to this user, providing these tools. We have a showcase place as well in the ONDA web portal, where all the people that derive an information, a service based on the ONDA virtual machine, then they can promote their activities. Not just helpful for them, it's also very important for us because we need to demonstrate the value that there is in using ONDA, in using this DIAS concept. Some evolution line, obviously, actually there is the Destination Earth, the Digital Twin Earth program that are starting, running. So we need that we have to optimize some configuration to respond to the new challenge in terms of accessing massive amount of data. So this dealing with a lot of data that are stored in specific places. User need to get a large volume in very short time frame and to process them using high computing capabilities. Kubernetes, we mentioned it. We are actually active in a Edge 2020 project where we do develop it, and it will become soon an on-the-shelf standard product for ONDA. And with respect to the VHR data, we know that many applications needed is complementary to the Sentinel ones. And we are actually building on top of the agreement that we set up with some providers to optimize the access to make it more efficient for the market, according to the profile of our customer. So we conclude with this maybe question that you raised, and you mentioned the bottlenecks. What are today the bottlenecks in using the platform? Again, the definition of platform is important. ONDA, as you have seen, is a layer in the backward on the first interface, that your graphical user interface that you had. But if I just think about platform as it is, and I use a platform and I want to have information, I think the first element is the maturity of the market. Are our customers in our community ready to use it? Do they want to use it? Do they see the value in it? And in say, it's not easy to say, who is the market? What is the market? So again, tell you, in front of us in ONDA, we have a huge heterogeneity of profile. So we know that the answer that we give to an expert is valid for him, it's great for them, but it's not good at all for someone that is starting with that. And if we have to boost the market, we need to also speak to some new startups that understand the value they get, but they need to better exploit our platform using specific ways, and we need to train them to do that. So I would say maturity of the market is a bottleneck, heterogeneity of profile is another one, but we need to maintain the granularity if we want to respond to all. Then how Eurogeo can help us to help mature the dialogue between the application and the infrastructure provider, the platform providers. First of all, obviously, continue to demonstrate the value, run project, give us framework where we can show to the overall community what can be done. But I would say maybe not just from a technical point of view. It would be good as well to assess, challenge the economic model that each platform is providing. And from that, based on the conclusion, maybe the stakeholders can have an overall landscape figure of the value they can get from these platforms. That's all. Thank you.
Well, thank you very much, Franck. I'm very happy to have sent you the questions because I think we are getting very valuable inputs on these topics. Next speaker will be Wendy Carrara from Soblu. Are you ready, Wendy?
Yeah, thank you very much, Marie-Françoise. I'll also be presenting with my colleague Laurent Lacoste. So I'll just share my screen. There. Is it okay, Marie-Françoise? Can you see my screen?
Yes, we can see your screen, Wendy.
Okay, perfect. So as it's the third presentation of the DS in a row, I won't go through all the details of what we offer. It's very similar to what has been said by Stanisław and by Franck right before. So there's the data part, the infrastructure part, the platform, as well as the services part. So in that respect, for the software, the platform, the infrastructure, or the data, it's pretty much, I would say, the same. Part of the difference of what we have on Soblu, if I can go to the next slide, here we go, is that we have the complementarity between the Soblu Copernicus environment, I would say, with the Copernicus Sentinel data, as well as the Copernicus core services. But we have since September integrated that with the Airbus One Atlas catalog that offers access to spot and play at high resolution and very high resolution imagery, but not only, because we're also giving access to the premium 2D and 3D layers that we've developed. The idea behind that is to address users' needs in so much that Copernicus Sentinel can remain the core source of data, but we're noticing that in more and more examples, users need higher resolution imagery sometimes to further identify whether it's a boat, whether it's a potential truck, whether it's a wildlife that they're monitoring. So there's a need for, let's say, surgical use of VHI data. So very practically speaking, since September, there's a single sign-on for both SoBlue and One Atlas, which enables users to go seamlessly from one platform to another. So maybe to answer Heike's comment in her presentation, it's not about pushing Airbus or Planet or whoever's images. It's really about ensuring that we put the user's needs first, and it's an easy customer journey for them to access the data that they need. And from my perspective, it would be the overall DIAS responsibility, or the overall Earth observation digital platform responsibility, to simplify the user journey. If I think back to the names on the list of your Wordle, Marie-Françoise, at the beginning, it's becoming more and more complex for users to find their way through this. And part of our responsibility as Earth observation digital providers is to simplify that user journey. So on the SoBlue side, this unified authentication is, I would say, a very first step towards a broader integration in the VHR and the Copernicus Sentinel world. I've emphasized a lot about users in this very short presentation. And for me, I mean, we can talk about users and we can say that we're doing things with users, but a lot of the feedback that we're collecting from the different entities that we're addressing, so the 200 plus paying customers that we have now, that they say is different about us is that we're going to spend quite a lot of time actually sitting down and listening to people's needs and addressing what makes the most sense for them, instead of, let's say, firing off a price list and saying, you know, figure out what you need. I'm exaggerating for the sake of making the point, of course, but this is also what I believe is part of our responsibility in the DIAS world, which is really about co-designing the right solution, because what is applicable to one specific user who's looking for, let's say, scenes of Sentinel-2 in Africa will not at all be the same need as someone who's looking for a time series over a given coastal area, etc., etc. And it's about that value that we're adding to the users, because DIAS is a bit of a dual world. It's fostering the uptake of Copernicus data, which is the first core pillar. And the other pillar of this dual nature is also to support processing on the fly and digital services that go along with data. So here I'm going to hand over to Laurent, because most of you are familiar with me and know that I'm definitely not a technical person. So Laurent, this is you to give us a few words about this specific focus on the Jupiter as a service offer that we've developed during the course of this year.
Yeah, hello. Thank you, Wendy. Could you hear me correctly? This is fine?
Yep.
Yeah, okay. My name is Laurent Lacoste. I am a solution architect. I'm working mostly on cloud systems and architecture. And today I'm going to show you our Jupiter as a service offer inside SoBlue platform based on a use case we had recently. We have divided our offer on two pillars. On your left, you have the build part, and on your right, the run part. We offer a cloud configuration infrastructure provisioning. This means we have some steps to be done inside cloud platform before using it. Before we have to create the project, creating the machine, the cluster, and a disk, all the needed resources we need. We offer also some application settings and deployment, because every resource have to be configured, like the network rules, firewall, backups, and only after that the deployment is possible. So these two steps are linked. Obviously, we offer in our configuration package, we offer document and tool management writing, because depending on the needs and the resources, we have to write some required documents, user guides, deployment tools, admin, graphical user interface documentation for the end user or the administrator. So this is a configuration package. inside the build, we have also the development package. What we call development package is divided in 5 points. The first is called analysis and specification. This point concerns time spent before the coding or implementation step. During this period, we will ask the customer to be sure we understand perfectly his needs, and we will write a functional and technical document review to validate it. Okay. Then we have to implement and develop our authentication gateway. This is a specific component we have developed, which is here to protect all the access to the system. Okay. We provide also a graphical admin user interface and APIs, of course. Admin graphical user interface is a web interface used for the customer admin to validate user registration request. And of course, we have implemented some APIs to in order to all the components can discuss themselves. We will see it after in a text diagram. We also provide support to data import because we have to import the data which have to be used inside the cloud provider bucket. And obviously, we have to do some tests before we cannot deploy a new application in production before testing it. Okay, so this is the build package with configuration and development. After the application is in production, we provide a run package, which is divided in 2 parts. For the first one, the support. Of course, we provide customer support on Solblue services. Our technical team is here to help in case of any problem. We have also a customer functional and technical follow-up. During the project life cycle, we also provide support to this customer because if his needs imply some change like configuration or advice on technical architecture, we are here to help. Also, maybe the system will evolve, so we will be there to adjust the component if possible. We also offer platform administration. This is from the cloud provider view. We are here to administrate settings, resources if the customer needs to adjust, of course. And maybe one of the big part of the deal is the cost management. We have 4 points. The first, cloud cost monitoring. We propose to create some specific cost monitoring to alert customer if the boundaries are reached. This aims to be proactive and informed before the limit is over. We also provide some new services subscription resources because what you have to keep in mind in the cloud world, adding new resources like CPU, new disk, databases have systematically an impact of what you will pay at the end of the month. So Airbus team is here to provide some advice and if needed to handle this action if you need more services or cloud resources. We also provide single point of contact. We are here to discuss with the cloud provider and to manage the relationship, of course. And a recurring reporting. We can implement some reports every week, every month to send to the customer his daily activity. So Wendy, you can go on the next slide, please. So here is a view of the high-level functional diagram about the solution related to Jupyter as a service. Obviously, we have not enough time to explain the detailed architecture, so the idea is just to show you how does it work from the user and the end user perspective. Okay, some technical points are voluntarily hidden to simplify the understanding. On the step 1 on your right, you can have a user from his own network. Okay, all the user connections are secured. They are secured by our authentication gateway. So the end user goes to the public web link from his own network or from anywhere with web connection. First of all, he has to fill in a registration form with some specific details, name, first name, email address, and blah, blah, blah. This request will be sent to an administrator to validate it. When this administrator validates the user request, this user will receive a specific confirmation email with link, credential, login, password to connect to Jupyter. And then we go to the step called 2A. After login, the user profile is loaded on the Jupyter Hub, and a dedicated Jupyter notebook is launched thanks to a Docker. Okay, so each user using Jupyter Hub has his own Docker running. Just a small stop on the step called 2B. The link from customer admin on your right to Jupyter Hub is a direct link provided only for the administrator. It can connect through the cloud provider console to use direct SSH or access the platform settings. Then, when the Docker is running, the Jupyter Hub, we are on step 3. Every time the Jupyter Hub wants to access data, the service code called WPS is asked by the Jupyter Hub, and the WPS process will receive the data and will send the request to the bucket on step 4. Okay, and the W process will receive the request from Jupyter Notebook. Okay, and on step 5, the result, the output is sent to Jupyter Notebook. If you make a focus on step 6, all the persistent data used and stored by the user are written in a specific bucket or a volume. So then the next time he will launch his Docker, the user will be able to retrieve his own data. And this is okay for me. I think I'm done.
Okay, thank you very much, Laurent. So again, I mean, it's really to address aspects that are often taken for granted in simplifying the access to the data, but also simplifying the access to the querying and to the infrastructure, and developing solutions that are meaningful for the different users that we're addressing. So that would conclude our presentation, and we're happy to stay tuned for the question and answers. Thank you very much. Back to you, Marie-Françoise.
Thank you very much. I apologize, but we do not have time for questions. We have already eaten the time for the Q&A. I'm sorry about that. I think we have to find some way to discuss because it is so interesting. So the next presentation will be Nuno Catarino from Nexios. Please, Nuno, stick to the 10 minutes because I don't want to squeeze Gregory, who is at the end.
Okay, thank you. How do I share the screen? Second. You need to give me permissions to share this. Here it is. Okay. Jerome.
We see your screen.
Okay, great. Thank you very much. So, hello everyone. My name is Nuno Catarino. I'm coordinating the Nexios project. So the Nexios is started as a H2020 project 3.5, almost 4 years ago, actually, and we set up to create a European data hub and platform to support pilot applications of European activities, European projects, and H2020s and others. So what we set up to do was to have a centralized data hub where you can have access to the data, can facilitate the access to the data, to have platform services that can help to deploy the data into an operational setting. And for this, we brought a number of pilot applications on board to test the full pipeline and the full processes. The context was, of course, Geo. That's given in the name of the project. So the group of Earth observations has a very clear mandate to support the use of Earth observations for the Sustainable Development Goals and Paris and Sendai agreements, and this is what we're supporting with Nexios, this community related to Geo. So I'll start with the end. So the pilots. So the pilots that we had that we have been working with through this for almost 4 years have been quite diversified. So we asked for quite a large number of thematic areas, so we can really test a more sustainable and systematic set of requirements. So we have two sets of pilots, one which we call innovative pilot services, which are more related to R&D activities, and another one of business pilot services, which are more oriented to commercialize services based on Earth observations. We had a set of pilots starting from the beginning. There were 10 project partners that became as pilot services. And then we onboarded a few more. We have here about 16 or 15. We have a few more in the pipeline. And the whole process was served to validate the engagement process and the several steps of the support that we provide in next years. So the services that we built up to now are the data cataloging. I'll show it later on what this is, so you can find the catalog online. It's a free cataloging service. This service will be maintained the next few years. We have resources to maintain it beyond. Actually, we have resources to maintain the services beyond the project lifetime already. So we have a data cataloging classic approach where we do the cataloging of the data, we do the matching of the metadata. This we're still defining and finalizing the approach until the end of the project. It's a free service. After that, there will be some kind of financial arrangement, but we have a semi-automated smart data cataloging service where you can build your own metadata profile, and this will continue to be a free service. So basically, if you want to catalog the data in the catalog, your project's data or data that you need to use in your project, this will be a free service in the next few years, at least 3 years. The service catalog is the same. It will continue to be a free service to publish your service in the catalog. Then, if you're an application developer, so the services that we have in this category are focused on moving R&D activities towards operational services. So we have the data discovery. This is of course open and free, and there's an open search API where you can put these routines in your. You can put open search calls in your code, and you can fetch data automatically. And we have the Sentinel data linker service and also quality of service implemented. So we make sure that the links provided are always the links that are working, and in the case of the Sentinels, that they are the fastest or the ones that allow for a smoothest access point. I stress that we do not store the data, so this is a very big difference with respect to the DS. We store the catalog of the data, and so the major advantage is that we have a centralized point for a huge amount of data. We have now almost 6 million data sets cataloged in the data hub. Then we have a user feedback mechanism. So for each data set, this mechanism is included in the online catalog, and you can also include it in your own applications. This is a tool done by CREAF for getting the feedback on the data that people access. And then we have a user management and authentication, authorization, and accounting service. So the authentication service that's free and will always continue to be free. But then we have the possibility of doing authorization of users of services. This will be a commercial service. It's now in the scope of the ESA network of resources. So you can get support for using the authentication and the accounting services through ESA, and we can help in this process. So the three services are basically the authentication is the service where the user gets authentication to be recognized in the system. The authorization is a service that you can connect your own application, and the system manages the authorization for use the service, and the authentication service accounts for the resources that have been used, or the time and whatever resources you want to take into account, so that you can, for example, either charge the service or have some kind of control. We are working on connecting to a billing system, but this is not yet closed, but it's being done in the scope of an ESA project as well. Then we have the cloud integration service. So this brings your service, which is deployed in your own resources. So it brings to any commercial cloud that you can choose, or you can have the support from Terra do and their cloud integration procedures to choose the best solution for you. And also when you have your service in a test cloud, let's say a reference platform, you can do the cloud bursting and use the scalability capabilities of the cloud, so you can provide the services to a lot more users and areas of interest. So these two are commercial offer services. They have been provided for free, let's say, or paid by the project within the project lifetime. As we are ending the scope of the project, there will be a commercial offer attached to this, but other solutions like participation in projects can also be envisaged. Then we have a final service of monitoring of services. So basically, when you set up your services, to have an operational dashboard set up on top of that, so you can have assure the quality of service on your application running towards your clients or your users. So this will also be a commercial service, depending on the type of services. So depending on the scope, there can be some support from Deimos for this service free of charge as well. So the data cataloging, service cataloging, and data discovery are implemented by Deimos, have been implemented by Deimos actually with the support with Datopian as well. I'm missing the logo from Datopian here, but they have done implementation on this, especially the Open Search API. They are implemented now with the support of NOAA, who is getting more and more datasets as well to the catalog. The catalog is, you can find the catalog online at catalog.nextuse.eu, and they are being supported by EGI and CESNet. So CESNet has kindly provided the baseline resources for free to have the service running for the next 3 years. This is the resources also for maintaining the service are being provided through Deimos by the Atlantic Collab. So they are also supported by them. We have a full-time FTE we have an FTE for the next 3 years to continue the support of these services. And then we have a number of other activities where we have and we are going to have more data. For example, we have Deimos imaging data for free there, a few data sets, and also we'll have exclusive data for the FSS CAPS mission. Well, that's an hyperspectral and GNSSR mission. We have the user management service that can be accessed through ESA in the COI and Network of Resources and the EOEPCA projects, and the cloud integration and bursting is also offered through the NOR, through the ESA NOR, and through the several tabs that had been mentioned before. The geospatial user feedback is supported by CREAF. They also support implementations in other services for free. And then we have the analytics and the operational dashboards, which are being used in eShape and in thematic services such as Nextland and Better, and in the ESA store for EO. This is an ESA activity that we're leading, where microservices in Earth observation are provided, costing tens of euros, or even eventually for free. So check out the servicesforyou.com website for that. And so the goal of next year is to be sustainable through the support of R&D programs, commercial services, and contributions and sponsorships. So these are the three ways that the next year intends to continue its path, because we think that no individual path is sustainable. So we want to gather this continued support, and we've been managing to ensure this for the next 3 years. So we want to gather this continued support to continue to serve the Earth observation community. Thank you very much. I think I had 1 minute or 2 minutes more.
Thank you very much, Nuno. We will jump to the next one, Grega, to avoid still to squeeze Gregory at the end. Are you ready, Grega? Thank you very much, Nuno.
Yeah, hopefully you hear me and see my screen.
We do. Thank you.
Okay, so I'll just run in. Hi, my name is Grega Milcinski, and I'll share some information on how Eurodata Cube can help you to get idea into the operational service, right? But first, to try to answer the questions that we have received, where I see the major bottlenecks in why that things are not really used as much as they could be, I would list these three as the most important one. First one is that people still don't understand what are actually the data that are available. We have lots and lots of data, but with more and more people coming into the game, they really are frustrated because they would expect that they get the Google Maps quality of imagery, but then every day or every few days, right? And this is simply impossible, and they don't understand this, they don't understand the NDVI and so on and so on. And then when we come into the commercial data, which do provide some level of the better resolution, then we bump into the data licensing and cost issue, which is extremely vague, if not, not just expensive, and this is not the major issue, it's just that it's difficult to really define it. Then second one is that people simply like to build stuff by themselves, right? That's something that I noticed in a couple of years already now. Even though things are there and they are available, people say, oh yeah, but I can do this better. And they do it. And then we are all building the same stuff rather than building on top of other things. And then, there is some reason for that also in the level of the services that they are there, because many of them are simply not operational, right? They work to some extent as more of a prototype. Many don't have a well-defined pricing. And so it's difficult to rely really on these things. And last but not least, then you have the closed platforms thing where people build the platforms which have lots and lots of features just to support different use cases, but then usually they're just the one missing that you need, and then you really can't use it. And even all-powerful Google Earth Engine has these issues, right? That you can't find everything, and then some people really avoid using it. Now, the Eurodata Cube's approach on how to solve this is shown in this nice, simple schema. But I'll not go into each and every box to avoid spending time. I'll rather guide on how we see that we can support really the different kind of applications and users. And our approach is more kind of the Amazon Web Services way, where you have several services that are independent yet integrated, and simply the users can pick any of them that they need, either one or a few of them. It's up to them, right? All the services are self-serving and operational, so they don't need to contact us. You can go somewhere, subscribe, and simply start using it. And they have the prices are clear. At least to some general use cases. Obviously, there's always cases where you need to discuss and find a better pricing model, but most of the things are actually already there. Now, where we go beyond the Amazon approach is that we do put quite a bit of effort into supporting each and every user. So those who contact us, we will take time and we will talk with them, even if they are not, committing hundreds of thousands of euros to our service. And I think that in this way, by actually making possible to choose what you need, then you can really start working on it. And where you start thinking about the ideas and the pilot, it's usually with the data. We support all sorts of data sets, most of the open data sets, including the commercial ones from Airbus and PlanetScope. And here I just want to mention that people can get quite a convenient pricing in terms of use, because you can buy by square kilometer rather than, by hundreds of square kilometers. So you have all this data. And now what you need to do is really to see which data fit your needs. And for that, we have the EO browser, which is free and open. You can browse almost all the data sets. not the commercial ones for obvious reasons, but everything else you can browse there in the browser without doing anything, just clicking in different visualization options. You see, you zoom in, you zoom out to see where the data are available on which days. It's always nice to get some temporal aspect, so you can do a time lapse simply to see how the things are changing and what you can actually see. And then if you are more advanced, you start looking for some patterns, like whether there is some, the harvest noticeable, something like that. All of this you can do in a simple web browser without even registering, right? Now, the next step is usually getting the data together with your own data. Right? You have, I don't know, administrative data sets, building outlines, whatever. For that, you have the powerful GIS tools out there like QGIS, ArcGIS, and the like, and you have the data already there. And we just help you bring the Earth observation data in that platform via a set of the interfaces, which are super easy to use and integrate in any kind of application. Now, the next step is modeling. And for modeling, the Jupyter Notebook is probably the most convenient way. You can do it on your laptop, or you can do it on the hosted Jupyter Lab if you like. Everything there with a simple click of a button. Now, then you actually need to do some end application for the user, right? And this usually, I mean, you can do it generically. If you want to do something that is really focused to your users, you need to implement it from scratch, let's say. But we do help you get all the relevant data insights. So not just the Earth observation data, but you can also host your own data in the Eurodata Cube and then stream them in the application. So you can build this kind of applications in a matter of hours or a matter of days. There are a couple of services out there to support you, like Sentinel Hub, GeoDB, and so on. And you can, I mean, it's important that it's not just about visualization, but also the raw data and the time series. So again, you just define how you'd like to get the data and you get it. And if you're not familiar with the different kind of processing scripts for the Earth observation data, we have a GitHub repository full of hundreds of different algorithms which you can find and just fine tune there for your own needs. Now, going into more advanced uses, if you really want to use the best out of the data that you can, there is an Xcube ecosystem available, integrating all sorts of Python libraries, not developed by us, but rather building on top of the open source things that are available out there, plus the added things that are by us. And you simply use these tools to explore the data, to analyze, to develop your models. And then when you have the model running, then you need a place to run this, to compute this data. You can do it again on your laptop if you like, you can do it on your virtual machine, or there is a EXCAP workspace where you can simply run the virtual machine to do that for you. So again, it's up to the user to choose what they will build. And then last but not least, if you have the application running and you want to showcase it, you can put it in our marketplace, either for free or for a revenue. And then we even help you collect these revenues for the user. Now, these services are widely used, so it's not something that we have just built and are waiting for users, but these are widely used and operational. And the best way to start is to go to the eurodatacube.com/register and you just create your trial account. Some more information here, and I'll conclude here so that Gregory has time.
Thank you very much, Grega. I'm sorry to make everyone run. Gregory, are you ready?
Yes, I'm ready. Thank you, Marie-Françoise. So do you see my screen?
We do.
Yeah, so I will go quick on the Swiss Data Cube, trying to stick with the time and to stay on time. So thank you for the opportunity to give this brief presentation on the Swiss Data Cube. So my presentation is a little bit different than the previous one, because we are more, I would say, a research infrastructure. So coming from the University of Geneva, working also and collaborating with the United Nations Environment Programme, the WSL, and the University of Zurich. So basically, on our side, the mandate that we have at the national scale, working for the Swiss government, is to provide evidence-based policy to support policy making. And obviously, we are trying to go in that direction of the data, information, knowledge, and wisdom hierarchy. So it's quite well known. So I will not spend too much time on this. But really, the big challenge that we have to face with satellite Earth observation data, it's how we can transform this really large volume of data into something useful to support evidence-based policy making. And the traditional way of using remote sensing images, it's a long process, as we all know. And now we really have the opportunity, thanks, for example, with all the dioceses, but also with the DataCube technology, to concentrate on the analysis side of the work and not on the pre-processing and cataloging and searching data. And probably one of the key messages of my presentation is obviously related to the data themselves. I think that the analysis ready data framework supported by CIOS is key. really for supporting users to spend more time in analyzing data than searching and pre-processing data. And from, I would say, a governmental perspective, these large amount of data are really useful to support the national reporting commitments that we have to provide synoptic information at the national scale that is also especially explicit. And thanks to the DataCube technology, we can have this really long baseline required to determine trends, to define the present situation, and even to inform the future when we think about modelization activities. So regarding the Swiss DataCube, now this is a national infrastructure where we have 36 years of Earth observation data. We have the entire Landsat and Sentinel-1 and 2 archive at different spatial resolution. We are ingesting new images every week. So it's now, I would say, a work that is going quite well at the national scale. But one of the key messages that I wanted also to bring through my presentation is that data sovereignty is really essential for countries, and really since the beginning of the work that we've done with the Swiss government, they were not looking to share data with Amazon or with whatever cloud provider infrastructure. They want to have their own national asset for running their own analysis. So that was really key for our country to develop this capacity at the national scale. So how we can work with the Swiss DataCube? Actually, you can contact us, and we will grant you an access to the cube. So we have a web-based interface that allows users to interact with the provided algorithm. So basically, you define an area of interest, you define your algorithm and the different parameters. You click on run, and then basically you have the result on the screen. Then you can download the data. And we have a Python API as well through the Jupyter Notebook that allows the different users to also to link with different Python libraries and so on. So it's, I would say, the traditional way now of working through the web. But we are not offering only data on Switzerland, but we are also providing access to data, some data in France, Germany, Austria, Liechtenstein, and also Italy. So if you have a use case in that area, you are more than welcome to contact us, and we'll be happy to work with you guys. Just to show you an example, so now we're working, helping the Swiss government to assess forest tree mortality because of the different droughts that we are facing over the last summer. So this is just a quick example. We're also supporting the government in ingesting the Sentinel-5P data. So now we have the full Sentinel-5P archive in the Swiss DataCube to track pollutant over the country for the COVID crisis. And just to give you also an example of what we have done with the Swiss DataCube together with the European Space Agency, the Group on Earth Observation, CNR, and the GRC. It's related to the SDG 15.3.1 on land degradation. And we have set up a full pipeline of analysis using the Datasets, using the GEOS platform, the DataCube, the Google Earth Engine, the EOSCAP, the virtual laboratory. And we have developed a generic methodology to assess this SDG across the entire data information knowledge pipeline. And now users have even the possibility to share the data through the GEOS server and then build a dashboard so that users can explore the result at various scales. So based on this activity, we have some messages for EuroGeo and eShape. I think this activity that we have run has brought different organizations to address European policy needs, and we are able to contribute probably globally. EuroGeo and eShape can really facilitate connecting and utilizing existing European development and knowledge and infrastructure. We can also push the ICT and EU cross-fertilization between the different actors across Europe. The methodology that we use is based on co-design, so it's a collaborative way of working together. Really, EuroGeo is here to connect and facilitate the connection between the dots. The open data, open algorithm is obviously well known, so I wouldn't spend too much time on this. But just to say that also the DataCube, the Swiss DataCube in particular, is here to support national digital strategy. Our vision is to support, obviously, and to be a national infrastructure in 3 years, more or less. But also what we have learned in building the Swiss Data Cube, there is a big interoperability challenge to make the different infrastructure interoperable. So now, on top of the Swiss Data Cube, we have the entire OGC stack of standards. So we have the WMS, WCS, WPS, CSW working. We are working in implementing also the stack standard on top of the cube. And we are aiming really to share also decision-ready product to the end user. So we have set up this geo network where you have time series data already prepared at the national scale that is available for free for anybody. And it's using and matching basically the SDI world with the long-term repository world. So it's also a way, so we are preparing a paper on that. And we're really committed to on the open and reproducible geoscience. So everything is open. The data, the notebooks, the publication, the code, and even the educational resources. For example, we have this bringing a data cube into practice that is freely available on our website. And to finish, we have developed this data cube on demand technology that allows anybody in the world to instantiate an open data cube instance based on just defining an area of interest, selecting a Landsat or a Sentinel sensor and a temporal frame, and then we instantiate a Docker image with all the necessary data, and then you have an access to a dedicated Jupyter notebook to work on your specific area. So it's up and running, it's working. And we're happy also to work with you on this. And just to finish my presentation, I think really the data cube technology, and even more, I would say all the platform that we have seen can really enhance the scientific accountability and credibility at the European scale, or even at the global scale, to take really sound decision on the environment. With that, I'm done, and I would like to thank you for your attention. Marie-Françoise, you need to unmute.
Thank you very much, Gregory, for everything, for the presentation, and to tell me that I was muted. So thank you all for your very good presentations. I got a lot of inputs from them. And I'm sorry because I have been a poor chair for two reasons. First, because we don't have time to discuss. Second, because people have asked some questions. And so we will capture the questions and send them to you to be able to address them into some document we will post, I think, on the website. Could you please send me also your presentations tonight, because I have to make a presentation in the closing plenary, and I will get a lot of inspiration from your inputs. So with that, I think they gave me 5 more minutes, but I have to wrap up because I have to give some feedbacks about your presentations in the next session. So what do you think? Personally, I have found this super interesting, and I would like to further the discussion. Would you agree to set a further discussion out of the General Assembly, of course, to be more relaxed and have less pressure? Sure. I think I have heard a lot of openings. You talk about integration, federating already several systems, either in-house like Airbus between SoBlue and One Atlas, but then also NextGeo's and a new opening with standards to prepare some integration. So would you agree to further the discussion into a meeting we could set later?
Yeah, with pleasure.
Yeah, sure. Thank you very much, Marie-Françoise.
Thank you all, and see you soon then for going further together. Bye-bye.
Thank you.
Bye.
Thank you very much. Bye-bye.
Bye-bye.
Bye.